Okay, hi everybody. Aloha and welcome to our October 2021 installment of Third Thursday, virtual Third Thursday, still yet. We're really happy that you're able to join us. We have a really interesting and exciting panel for you today. A few announcements I wanted to make about the center before we get started. First of all, we have just been reaccredited again for another 5-year term by the International Accreditors for Continuing Education and Training, or IACET. This process started back in the late spring with our self-study. They did their site visit, a virtual site visit in September, and we just shortly thereafter found out that we had been reaccredited, and that will go through 2027, January 2027. So we're really happy about that, and a big shout out to all of the staff who put in a lot of time and effort to prepare the self-study and to meet with their representative on the visit. Okay. Our delivery team is just, they, I guess, are not planning on doing any shopping this Christmas season because they have scheduled a crazy number of deliveries over the next 8 weeks or so, up until the middle of December. We have 35 deliveries scheduled. 30 of those are virtual, 5 are in person. We're doing some in-person deliveries in Michigan, I believe. And so they are working hard to meet the demand out there. I just checked the delivery schedule, and we're actually scheduling deliveries out for to next October. So October of 2022, we actually have some deliveries scheduled already. So our folks are working really hard to bring those courses out to everyone. The development folks have been hard at work as well. This calendar year, we recertified 8 of our courses, which is an incredible number. It's partly a function of the fact that we now have, about 24 courses, and FEMA has us recertify these every 3 years. And it's not just a matter of updating the content, but also demonstrating the continuing need for the course. So it is an extensive process, but it's there to ensure that the courses that we provide, number one, are still needed, and number two, have the latest information and guidance that is available. So another shout out to our development folks who are working hard as well. Okay. Normally, we haven't even started today yet, really, but I want to say, please save the date for next month. We will be having another virtual Third Thursday on November 18th. So we're not going to interfere with your Thanksgiving plans. We usually try to announce that at the end of the presentation, but inevitably we end up talking until the last second and not being able to say that. So save the date for next month. We will be offering something next month, and you will see more details on that shortly come out. Okay. All right. So without further ado, I'd like to turn everything over to our executive director, Dr. Carl Kim, who will introduce you to today's topic and speakers. Carl?
Thank you, Russell. And it's great to see you all. And again, we do these monthly gatherings to check in on each other. I hope you all are staying safe and healthy and engaged. We are really trying to move towards more normal face-to-face operations with especially for the next semester. And so we're transitioning, I think, more to normal operations, or operations as we used to run them. And again, because so much of our staff are on the call, I want to again acknowledge and thank all of you for the really hard work that you've been doing. It's not just in terms of the reaccreditation or the certifications, but really the hard work of scheduling and pulling off the deliveries which need to go on. And so, again, very heartfelt thanks to each and every one of you for your hard work. One of the reasons we have these third Thursdays is to share research and engage with the people that are working on, I think, important projects. And today's session is no different. And it really focuses on both work that we're doing with National Disaster Preparedness Training Center, but also part of our Region 9 Pacific Southwest UTC. This is a regional university transportation center. And what we're looking at today is vetiver, grass, green infrastructure, and transportation resilience. And we really have three excellent speakers or participants, and maybe others will join in. I hope Liz Fisher is on as well too, because she's been involved in some of the research we've been doing on this topic. The first is coming all the way from Jackson, Mississippi, is Dr. Sadik Khan, and he's an associate professor in the Department of Civil and Environmental Engineering at Jackson State College. And he's really an expert on vetiver. Our other speaker is Jason Fox, who's I think coming to us from Hawaii County, where he is one of the only certified vetiver growers in the United States and operates his organic farm, Vetiver Farms Hawaii. And then Sequoia Riley, who many of you in the center know. She's a Ph.D. candidate and researcher with our National Disaster Preparedness Training Center, and she's doing a dissertation on green infrastructure. So with that, I want to hand it over to Sequoia, who I think is going to get us started for today.
All right. Hi, everyone. Thanks, Dr. Kim. So as you stated, yes, my name is Sequoia Riley. I'm a PhD candidate at University of Hawaii at Manoa campus in the Urban and Regional Planning Department. And I'm going to share my presentation. 1 second. Can everybody see it? Is everybody good? Okay. Great. All right. So this is a paper that Dr. Kim, Liz Fisher, Dr. Sadik Khan, and I have worked on this past summer. And the title of the paper is Green Roadway Infrastructure with Vetiver Grass to Support Transportation Resilience. So, okay. All right, so what was the purpose of the paper? Well, the purpose of the paper was we wanted to investigate vetiver as a green infrastructure and hazard mitigation tool for transportation planning, looking at not just the benefits of it, but also the barriers and also the opportunities to use here in the US. And the reason why is because with climate change creating more intense storms and which also results to flooding, be it riverine or sea level rise, it is causing a significant risk to transportation infrastructure and other coastal infrastructure such as hillside slopes. And that failure of the structures, it's not just landslides and erosion due to washout, but the piping and overtopping is also a result of that as well. So many of the, as we call it, gray infrastructure, And when I say gray, if you don't know what I mean by gray, I mean man-made structures such as like what we have right now, roadways, culverts, dams, dikes, and underground piping. All that is man-made. So, we feel that many of the infrastructures can be repaired or retrofitted with Vetiver in a green and cost-effective manner. So what is Vetiver? Vetiver, as you can see in the picture here, is a non-woody grass. It originates from Southeast Asia and Africa, and is environmentally friendly, non-invasive, and essentially it was used for essential oils and agricultural applications. It still is, as far as agricultural applications go. Oils, it still is, but not as much. But it has and still is also being used for flood mitigation and landslide mitigation purposes. Hence, it is considered a green infrastructure tool. Why? Because again, like I stated, it's flood resistant, ability to mitigate landslides, but it's also low cost and low maintenance. So before we get into the rest of the paper, let's talk about what green infrastructure is. So what is it? It's a very ambiguous concept. It can be used, it benefits socially, economically, and environmentally. But overall, it is a multi-spatial, nature-based design approach where it's much more adaptable than gray infrastructure in terms of thresholds. There are certain gray infrastructure tools or gray infrastructure overall that cannot handle certain amounts of flood or landslides to a certain degree, which is why green infrastructure is an optimal option. So some examples of green infrastructure is you have stuff that's really big, like such as permeable or porous pavements, going to green roofs and blue roofs, and then bioswales, and then vetiver. So highway and transportation applications as a green infrastructure tool. Well, vetiver, as I stated, it originated from Southeast Asia and Africa, and it has been used on a global scale, minus the US. I mean, there's certain parts of the US that have used it, but not enough to say that it is becoming a popular tool for transportation application. So globally, it is being used to buffer roadways to support filtration and flood control and hillside stabilization, including erosion reduction. And the thing is that while we understand that it's being used on a global scale, we wanted to understand why is it not being used as much in the US as it is in different parts of the world outside the US. So what me and Dr. Sadik Khan and Dr. Kim and Liz have done is we've actually gone out to interview multiple stakeholders from different disciplines, not just planners, but or ecologists, but also biologists and transportation engineers and other planners as well, and also those who are also experts and have used vetiver as well in different parts of the US. And so what they have stated is, vetiver is rarely used within the US. And I mean, even if you went to go on, like, say, Google Scholar to search up where else vetiver has been used in the US, you're not going to find much. And in the US, it also has not been used widely for hazard mitigation purposes. And as I stated before, it has been incorporated into smaller projects such as Galveston, Texas, Biloxi, and Jackson, Mississippi. But those case study examples I mentioned, 2 out of 3 have only really used it more so for watershed purposes, not so much for landslide mitigation or flood mitigation. But with Jackson, Mississippi, this is where Dr. Sadik Khan comes in, if you would like to chime in, about how you have been using or how you've applied vetiver into Jackson, Mississippi. But also I want to bring in Jason as well, because vetiver is also being used in the big state of Hawaii. So if you guys would like to talk a little bit more about that, of how you have implemented Vetiver, or what you are using it for, please. We would really like to hear that. We'll start with Jason.
Thanks, Sequoia. I really appreciate you taking the time to make that presentation. I've been trying for so many years to disseminate Vetiver in the United States, in Hawaii specifically. And yeah, not many people know about it. So it's awesome to see that all put together and that people are interested in it. It's usually me kind of, I'm not so good at disseminating math and engineering. So I'm really glad to see other people that might be able to help out with that, because I'd say that's probably our biggest hiccup with getting Vetiver used more with the state, is not being able to quantify some of the math that the civil engineers are looking for. I've worked with this plant in Hawaii for like 14 years, and we've worked in Tahiti and Thailand and Vietnam, and it's pretty popular in Asia. A lot of engineers will use it. I think that's mainly for cost reasons, and accessibility is probably why it's so popular in those places. Like when we were trying to explain to the engineers in Tahiti to kind of steer away from shotcrete that didn't have drains, we know that the tensile strength of a vetiver root is 75 megapixels, and each plant is about 3 feet wide. So when you do a rough estimate of each plant, you can assume that they're similar to 4-inch steel plates. There's another level that needs to go to in order for this plant to be spec'd into a lot of civil engineering plans. So a lot of the work we've done out here has been for residential home stabilizations. We stabilized a lot of the satellites at the Pacific Missile Range in Hawaii, the landfill in Lanai, a lot of the parks in Maui. But in theme of the larger scale transportation, I think that's something that this plant, myself, would definitely be reaching out to people who are more, in the academic realm, because our focus is pretty much just on installation and wholesale plant providing.
Yeah, and that's a really good transition, I think, to Dr. Khan's presentation. So maybe Sequoia, you can stop screen sharing, and Sadik, if you can bring up your presentation, I think that's a nice transition.
Yes, I can do that. So should I go ahead and make my full presentation, or I'll just talk
Sure,
about a few
sure.
things?
Yeah, why don't you go ahead and make your full presentation,
Okay.
right?
Okay, sure. Hi all, I'm Sadik. Oh, sorry. Technology. Let me share my screen. Can you see my screen?
Yes, it's beautiful.
Okay, perfect. Hey all, first of all, I'd like to thank Carl, Sequoia, and everyone for inviting me on this excellent opportunity of collaboration. And I want to give you a very little background of mine. I usually work with the Landslides, and my PhD was on the Landslides. I worked on a different technique where I have used recycled plastic pins. It's a slender type of pin that we used in the highway embankments, fixed many highway slopes. It has been adopted as one of the technique, which has been adopted by the Texas Department of Transportation and Mississippi Department of Transportation. So it's from the research, it already been implemented. So I stopped doing the research on the pins. And then I was looking at other options of fixing the slopes. So when I started looking at other options of fixing the slopes, I know about Vetiver, but I never tried it, honestly speaking. So when I looking at all the problems, and I also work with like different aspects of the landslides, which is one of the biggest issue in this area in Mississippi, you know, especially for the DOTs. Then I looking at some solutions, and I become a very big fan of Vetiver immediately, as long as I started looking into the problem, you know. So my presentation is all about how we can use Vetiver as a civil engineer to fix our infrastructures, you know, and this infrastructure includes transportation infrastructure as well as other infrastructure. It's a great solution for flood control infrastructure too, like the levees. So the presentation I have is the climate adaptive green infrastructure. So many keywords, you know, for using deep-rooted vetiver grass. And I wanted to start with the hurricanes, the recent hurricanes that we are having, especially on the Gulf, you know. We just have like 4 major hurricanes with a category 4, all hit either Louisiana, Texas, or Mississippi within the last 4 years, you know. Look at the damage numbers: 125 billion, close to 20 billion, not million, 3 billion and 65 billion. The recent one is the Ida, and it caused like around 125 casualties. So it becomes a very big issue. Now, what the question is, why we have so many? Answer is because of the climate change, no question about it. And why? First of all, if we look at the temperature, you know, climate change, because of the climate change, we have the global warming, temperature goes up. As the temperature goes up, the moisture carrying capacity of the air goes up, you know. So moisture carrying capacity goes up means we have more moisture into the air. So we have more clouds, we have more precipitation, plain and simple. And this is how it looks like as the precipitation, you know. Now, the problem is what we have along the south is we have a higher temperature. We are talking about the high temperature in Texas. So you know, here is the high temperature, and also we have a very large amount of rainfall. So there is 2 problems. And if we look at how it has been changed over the years, you know, it's on the south, the increase in temperature is not much, but the changes in the precipitation is huge. It's close to around 20 to 30%, you know. So that creates a major problem. So in the south, we have in the south we have the expansive soil, and expansive soil creates lots of hiccups to Texas, to some part of the Louisiana, Mississippi, and Alabama. You know, I'm not very familiar about the Florida soil types. I know it's quite sandy, but I'm not very sure if they have the clay soil. But these 4 states, if we start from Texas to Mississippi, Texas to Alabama, we have like the expansive soil, and that expansive soil is like a clay soil, very high pH clay, which has the shrinkage behavior. Like if it gets dried, it has lots of shrinkage cracks, and when it gets wet, it swells and it creates so many problems. So because of the existence of this expansive soil, the landslides are very common. It's not only in Mississippi, but it is very common from Texas to Alabama. It's very common. Whenever there is expansive soil, you always see like this type of failure. Now, to fix this type of failure, it takes around 600 to 1 million. You know, that's the average number. The average number to fix one single landslide for Mississippi DOT is around 1 million. And I was trying to look at some of the cost-effective options, and Vetiver plays a big role there. But before going there, I wanted to emphasize some of the problems that we have, and from the civil engineering perspective. I wanted to make it like really simple. So to understand, the expansive soil has a very high shear strength, but when it exposed to different wetting and drying cycles, what happens there, the shear strength of the soil is becoming softer, and because of that, the shear strength keep dropping. So at the beginning, when a embankment is constructed, like a levee or highway embankment, it has a very high shear strength, but over the time, the shear strength keeps dropping, and that makes the structure weaker. That's one problem. The second one is we have the shrinkage cracks during the summer because the high PI clay or the expansive soil has several formation of the cracks, like the desiccation cracks, and that allows the rainwater to infiltrate it into the slopes. So that's create another problem. And then we have done a study, and within that study, we are trying to look at how our slopes for MDOT is performing, And what we have seen, we have instrumented, we have heavily instrumented 6 slopes, installed many sensors, and then trying to look at how the soil moisture is playing with the rainfall. So here is the rainfall. All the black bars are the rainfalls. And within the rainfalls, what we have seen is we have a constant moisture content. It's a constant moisture content. I really didn't expect that. I expected that we have some bumps and drops within these lines. It's because we have the cracks. So we expected during the summertime, within the cracks, first of all, during the summertime, we expected the soil will get dry, and then within the cracks, water will get in. So we'll see some kind of wetting and drying. But here, we haven't seen any kind of wetting and drying, and this is not normal. So first of all, at the beginning, I thought maybe we're not doing it right, but we have instrumented it in many locations, and all of our results are pretty much like this. It's a flat line. Now, we're thinking about why it's a flat line, and we think what happens there is a bathtub conditions. Because of the climate change, there is a very high amount of rainfall. And with that high amount of rainfall, it already have like 30% increase in this area in the rainfall. So there is like more infiltration. And that more infiltration is making the slopes really, really wet. And because of that, we also have seen the slope that we instrumented and monitoring, the slope is moving. The slope is kind of failing. And it's a very slow process, but it's failing. So we also to check our hypothesis, what we also have done, we have the actual rainfall data. We simulated that amount of rainfall, and we tried to see how it is going to affect the factor of safety of the slopes. And we have seen that with the infiltration, the factor of safety of slope is dropping. It started from 1.2 and it is close to 1.1. And if we continue, I know it's going to fail. We can simulate the exact failure that the slope is having. And just for your information, factor of safety 1 is failure. So we are close to 1. It's like 1.1 just after some rainfall here, So to investigate it further, what we have done, we did a electrical resistivity imaging. It's kind of like sounding like an MRI testing of the soil. So in this test, what we have done is we injected current through the slopes, and while we injected current, we are measuring the resistance. Now, if the soil contains water, especially the clay soil, what happens, the clay soil becomes like superconductive. So superconductive means the resistance is really, really low. So right here, if you look at this number, the 2 is the lowest resistance. The lowest resistance from the resistivity you can get is 1. And here we are getting 2. So it's like really, really low. And this is what we are seeing through our slopes. So this is the line that we are doing the resistivity, and the results looks like this. So it's all wet. So if I want to summarize what is happening here in Mississippi, first of all, we have the summer. During the summer, we have the cracks within the soil. Through the cracks, water gets in, and then the infiltrated water is sitting there. It's not moving out. And then during the fall to spring, what happens there, the temperature goes down, And during that time, whatever the water is infiltrated into the slope, it stays into the slope. It's not moving out. The next year, it's happening again. The following year, it happens again. So it's a cyclic process. And through that process, the soil develops a parched water condition. So the parched water means the soil becomes really soft, really wet, and it stays like this. And because of that, in the recent last 2-3 years, we have seen so many landslides is happening into the highway magnets. So many. Like last year, the MDOT repaired 40 landslides, whereas like 5 years back, they usually have like 5 to 10. That's their common numbers. But right now, that number is like around 40, and I'm expecting that number will go up. I'm serious. So to mitigate this problem, we need to have some kind of repair technique, which is going to solve the problem from every perspective. And that's where the vetiver plays a big game. So vetiver, it has a deep root system. So it can go as much as 10 to 12 feet, and you can look at the roots. It's distributed, so, and it has a very high tensile strength. Now, as we know, vetiver has been tested in different countries, but it never been tested in US like this. So there is a very big resistance of using vetiver, and I feel like the major resistance was we didn't have any systematic study from the civil engineering perspective to study and how we can use the vetiver. And I think this is the first time we are doing it. So I'm really, really excited to do it. So now let's look at the problem, what we are having in Mississippi. We have the infiltrated water, which makes the soil soft and wet. So every year we have the shrinkage cracks, water gets in, infiltrated in, and water is sitting there. If we use the vetiver added 3 things, not 1. Vetiver added 3 things. First of all, vetiver has a high tensile strength. The vetiver roots has a high tensile strength, which is 75 MPa or 10 KSI, which is 1/6 of the tensile strength of the river. So it works like a soil anchor. It will try to hold the soil in place, which is huge. It offers a tensile strength, which is a bio-anchor. That's the one. The second one is vetiver roots are distributed. So that root work as a reinforcement within the soil. So every time there is a wetting and drying, the soil is trying to form some cracks. The roots is trying to hold the soil in place. So when the roots are trying to hold the soil in place, it's cutting down the amount of the cracks, and that will cut down the amount of infiltration into the soil. The third one, and this is the best one, vetiver acts like a vertical drain. What happens there, vetiver has the evapotranspiration. It can suck out the water. And what happens, our soils are wet, already been wet. So vetiver will draw the water from the soil, make it dry. Making the soil dry will immediately solve the problem. No civil engineering methods can do that. This is where the vetiver plays a unique thing. And if we forget everything, just because of its nature to draw the water out from the slopes, it's a game changer. So to test it, what we are doing, we have two slopes. One is it's a levee in Arctic, and we have planted vetiver. I have some photos. So we have planted vetiver at different spacings just to test it. So what we did, right here, we have like 8-inch spacing. I have another slide where I have done it in a different fashion. So for these slopes, we have like 1,000 vetiver slips. And I think we did it in 2 days. We're not very expert on planting. So it took longer time, but this is how it looks like now. So all the vetiver has grown, and we also instrumented it, So we are also monitoring the results of how the vetiver is drawing the water. So maybe I can make another presentation as I have like more data on how Vetiver is drawing the water out from the soil. So the same slope that I talked about, which is the terror slope, which was moving, we planted Vetiver at this point, you know, and that slope was moving. The slope was moving, but as long as we planted Vetiver at this point, we are not seeing much movement. I don't want to say that is working right now. We just have done it like 6 to 8 months, but I'm expecting within a year or so, this movement will be completely stopped. So in these slopes, what we have done, we have planted Vetiver at 1 feet spacing. It's a highway slope. It's not a levee slope. So it's a highway slope. And we have planted Vetiver. And this is how it looks like after fully grown Vetiver. So for this one, I also have done some modeling. And so for this one, the way Vetiver, the way this slope has the problem is the slope is wet, it's cutting down the factor of safety. Now, if we add Vetiver and we model it with the evapotranspiration nature of the Vetiver as well as a bioanchor, that factor of safety of the slopes goes up to 1.6, you know, with few $1,000s. Usually it takes to make a slope with a factor of safety 1.6, it will take around $400,000 to $500,000, the same area that we repaired with the Vetiver. So there is absolutely no doubt it's going to transform how we fix the slopes. And it's a great example of how we can use the Vetiver for the green infrastructure. And I always talk it as a climate adaptive design because it will sustain within the climate. You know, whatever the loading is coming from the climate, like the rainfall, temperature, and all other parameters, Vetiver works against everything. And that's the key. Per square feet cost of Vetiver is around $5 to $7. If we compare it with the plastic bin, it's $10. If we compare it with the soil nail, $40 to $50. If we compare it with the piles, it's around $70 to $80 per square feet. That's the number. So Vetiver is only $5 to $7, and it really works. So the other things I'm currently working on and looking to use it for is like using Vetiver to strengthen the slopes against overtopping and to tackle the erosions. Those are kind of like a major issues on the levees and on the coastal infrastructures. So maybe I'll present you those results as well. That's pretty much it from me. I would like to thank the funding agencies. This project was funded by National Science Foundation, is funded by its ongoing project, so it's funded by National Science Foundation. Also have a UTC grant to work on the Vetiver. So I'd like to thank those major players. And then I really appreciate the contribution from MDOT. And I think we will be able to do some repairs, the actual repairs with Vetiver in the coming years. So I'll be looking forward to it for sure. So that's pretty much it from me.
That's really great presentation. And I know there were some comments that were posted in the chat section. And so if you can stop your screen sharing, then I think Sequoia wanted to bring together some arguments in terms of barriers and that we've encountered in terms of our research and the paper that we worked on.
Yes, and I will bring that up. Okay, so thank you, Dr. Khan, for that great presentation, and thank you, Jason, for providing more information about with your expertise on Vetiver. So I am going to try to make this as short and sweet as possible. So there were so as far as barriers go when it comes to implementing green infrastructure, and which also includes Vetiver. I mean, there's various factors that play into where Vetiver is most suitable, and Dr. Khan did talk about that in depth as to where it is what is most suitable to that. And then also so there's institutional, physical, environmental, sociocultural, and economic barriers. So the institutional being, reliance on conventional grain infrastructure. That's one. There's inadequate data, unfortunately, on the ecological benefits and the social returns of vetiver. And then there's also maintenance and then long-term impact on native species. Okay. So now, as far as opportunities go, we found that, an opportunity would be to integrate vetiver with living shorelines and watershed management. Vetiver works pretty well in those environments, not just mixing it in with gray infrastructure. But before we really even begin to think about integrating that, what really needs to happen, the core thing that needs to happen is training and education to build capacity on understanding the benefits and also the barriers of using vetiver, and more collaboration across disciplines like landscape architects, ecologists, biologists, transportation planners, transportation engineers, so on and so forth. More collaboration is needed across those disciplines. We also need stronger advocacy for vetiver, and as I stated before, more holistic, integrative, collaborative approach. So I'm going to skip this because this all goes into what Dr. Khan has discussed as far as what is considered suitable and what the key functions are of using, of implementing and using vetiver. One thing I do want to point out is on this slide here, you can see that other alternatives, as I mentioned, like stating, there are other plants to use aside from vetiver are native species, because in some areas such as in Hawaii and Kauai, one of the things that was brought up from one of our reviewers is that the community may be very concerned about using something. While it is considered non-invasive, they would still be concerned of how non-invasive it is. So a list of native species, at least here in Hawaii, you have love grass, the pili grass, pala'a, and makaloa. So really quickly, as far as case study goes, in 2018, Kauai, I'm sure a lot of you know who live here in Hawaii, but for those who are not familiar, in 2018, there was a major flood and landslide event that occurred in North Shore, Kauai. And unfortunately, vetiver and other green infrastructure tools were not really considered to use for mitigation purposes. They still went back to, when I say they, I mean the Federal Highway Agency wanted to go back to using conventional engineering and repair approaches. So this also ties into my dissertation work, which is looking at not just North Shore Kauai, but Alawai watershed and Waimanalo. Why? Because they all, it's all different scale development going from rural to urban. They all recently experienced flood disasters, very little mitigation planning, and there was major emphasis on gray infrastructure. So to kind of just summarize, not really summarize, but just to bring back into discussion, and please feel free to also ask any questions as far as, other barriers or opportunities you think would work. I'm speaking to the entire audience here. I would like to hear you guys chime in on that. Is the reality is more complicated. As I stated before, the barriers are physical, institutional, sociocultural, and economic. There needs to be better studies, tests, and implementing of green affordable solutions, such as using vetiver. Training and education is majorly needed. We can integrate green and gray infrastructure. It is a possibility to do that. It actually would be an optimal idea to do that, and new governance approaches. So in conclusion, what we found overall is there's limited awareness and understanding of green infrastructure. There needs to be coursework development on green infrastructure overall, convergence of interdisciplinary, transdisciplinary policy, funding, priority changes need to take place. Realizing that, it's not just Kauai that is dealing with, landslides and flooding and needing to use green approaches to mitigate that, to keep areas more sustainable and resilient. But planning also needs to take place to better planning urban and transportation to improve quality of life, where it includes equitable distribution. So just to recap, we need to address barriers through education, training, research on both successful applications and benefit cost analysis, and more engagement with and convergence across disciplines. Overall, as I stated, so the next steps would be, look at native species that might be more preferable to vetiver, start something small, like a small project. And this is where Jason, you can chime in as well. We need to integrate local knowledge, collaborate with Transportation Research Board, and do long-term monitoring and evaluation. So all this ties to NDPTC courses. Me and Robert Poro, I don't know if he's in the audience right now. We are both working on putting together a training course on green infrastructure, nature-based solutions. But this whole paper can also ties into like helping to build on the land use planning and mitigation course, along with the climate adaptation for emergency management, flood hazards, science and preparedness, and community planning for disaster recovery. Last course also that would be good to tie in is the planning for disaster debris management as well. So mahalo nui loa, thank you. And I'm going to stop sharing real quick and get back into, bringing Dr. Khan and Jason into the facilitation, into the mix of discussion. So I want to start with you, Dr. Khan. Can you compare plastic, you said plastic pens, correct? Yes. Can you compare that to vetiver? Like, what are the advantages and disadvantages and the costs and barriers to that?
Plastic pin and vetiver both are like very similar type of solution. Plastic pin comes from the recycled plastic waste, So it is also considered as a green solution because it's been used for to divert some plastic waste from the landfill. But vetiver, when I started working on the vetiver, now what I'm doing is I'm merging the vetiver and plastic pin. It's for a different application. So vetiver and so let's talk about the vetiver first. Vetiver has many advantages and one disadvantage, that is we need to wait to grow, So in terms of, and I find out that it's a barrier for the duties to fix the slopes. Because when I started talking to them that we can use the vetiver, the first question they asked me how long it takes to grow. So we need to have some kind of system in between, which we should be cost effective and give some kind of solution within the timeline that allow vetiver to grow. So we can design a system which one system complement to others, and that's where I'm thinking about using the vetiver and pins together. But vetiver is a tremendous solution for proactive maintenance, and this is where I am being really vocal on. The current way infrastructure is repaired, we need to wait for the money, Everyone wait till it fails, not before it's repaired. For example, the slopes that we planted vetiver, after we planted vetiver, the movement stopped, right? So that's the optimum time of fixing the infrastructure. It can be repaired within maybe less than $50,000. If we let it fail, it's gonna take more than $500,000. There is no question on that, So using the same amount of money, if we plant vetiver, we can fix more than 10 slopes with the same amount of money, and that's where the vetiver is the key. That's one. Now, if it's a repair, then we have to accommodate, we need to look at different options, and vetiver also plays a big part there. But it might be needed, especially in our culture in US. We need to have, we still try to build the rigid structures. We are not still into the soft infrastructures, I think we need to have a learning curve till we go for the soft infrastructures. But till now, we need to have, even if we go for a rigid infrastructure, vetiver still plays a big part there, because we don't need to have piles like at the middle, at the crest and at the top of the slopes. We can just have the piles, even if we wanted to go with the piles, but the rest of the part we can plant vetiver. So we have the peace of mind from the designer's perspective and achieve the cost effectiveness and the green infrastructure from the ecological perspective. So we can combine it both, you know.
That's really interesting, this notion of maybe using the plastic pins initially, and then introducing the vetiver.
Yeah,
And then
absolutely.
maybe
Absolutely.
pulling the pins out and reusing them. You know, we've been very concerned about plastic debris, and so trying to think about those types of solutions. That's really quite interesting. There've been quite a few questions about the performance in coastal areas, on sandy soils, on other types of environments. I don't know whether you or Jason can kind of respond to how well does vetiver work in, is it salt tolerant? Does it
Yeah,
grow well?
it's salt tolerant. It works on the sandy soil. You know, the major challenge when I first tried to use vetiver, the first challenge I had is, does it grow in the high pH clay? You know, that's because usually most of the plant doesn't grow in the high pH clay. So high pH clay is like considered as one of those type of clay, but it grows there. That's the great advantage. In sandy soil, vetiver works. There are tons of literature where vetiver has been tested in the sandy soils. So it works in the sandy soil. It works in the salty environment. I know, especially in Bangladesh, I know a few collaborators of mine. They work with vetiver in the sandy soil. So and they use it for the coastal application. It works great. Now vetiver can, as we started working on the vetiver, I see tremendous applications of vetiver, not only on the slopes but in many different applications. You know, so yeah, to answer the question, simple answer is yes.
Yeah, I want to turn to Jason and ask Jason to comment on his experience in Hawaii, any coastal applications, and what is your experience?
Yeah, that's a trickier one. I think salt tolerance can be kind of a vague word. Salt buildup in soil can be great for the soil and it can be horrible. We implement gypsum a lot of times to help absorb the high salt content. So in Hawaii, compared to other places in the world, we have heavy trade winds. Like one of our applications that we're working on today is at a giant wave break. So we're talking about an extreme amount of salt being flown into the plants and the soil. I've done a lot of coastal stabilizations on all the islands, and every application is different. How high is the freshwater table? How high is the saltwater table? How high is the concentration in the soil upon arriving at the site? So for usually when we walk onto a site, we throw down ryegrass as like, you know, maybe something similar to the plastic pins that I'd be curious to see. So that mitigates our surface erosion while we're working, and that's a cheap, quick sprout. And then we implement a lot of different species, and it depends on where it is. With coastal applications, I started off using a kuli, which is a native vine-like species. It does it's like extremely salt tolerant in the sense of, I don't know the quantification for salt tolerance levels, but vetiver does rank high on that, and it is good, but I mean, we're really pushing the limits with some of these applications. So a kuli was okay. It didn't provide a salt block. So now what we do every time we're doing a salt block is we're implementing Pohinahina or Naupaka as a front barrier, because you really want the, like, you know, this conversation is so great and it's giving so much attention to vetiver, and the part that I really want to be cautious of is not, you know, testing this plant and seeing it as a fail just because there was some other variables that, you know, like I've screwed up many times in my plantings, especially with saltwater, where I wasn't caring enough for the soil, or I wasn't giving enough attention to how much salt was coming in. So Pohinahina and Naupaka are kind of our first line of defense on these shoreline applications. And once that heavy salt spray is blocked, then our plant is performing the way we want it to, and we're getting that 75 megapixel and not a spindly plant that's not doing well. And what also a thing we're doing that I really love is in East Hawaii on the Big Island, we've stabilized most of Honolulu Beach. It's a pretty famous surf spot. And we've been stapling seashore pass pound to the cliff. So that's addressing the wind erosion and the super high salt concentration and surface erosion. And then we're establishing vetiver plants up top, and these cliffs face east. So your performance on your vetiver, it's not getting enough sun and it's getting too much salt. So it's not performing well, and it's wasting our time and the customer's money on maintaining something that's not working. So yeah, that's where like the Pohinahina is a new one that I started using because it's a low growing shrub. It's kind of the perfect height. And at this point, like, you know, and this is 15 years of testing on different applications, the Pohinahina and the Pohinahina and the Naupaka are the only two that really work well to help the vetiver thrive. And you have to hedge the Naupaka, otherwise it creates a draping effect, which is what's happening on a lot of these coastlines, and it's masking the erosion, and then you're having these fails. And they're all, you know, it's very different when you go from a 200-foot cliff to a 3-foot high beach property planting. And I really agree with like the manual aspect. I'd love to participate in that and get that out there. Like plant spacing is important. We do ours 6 inches apart. The health of the plant, the age of the plant, the soil, most importantly too, just loading up on compost and having it be full exposure to sun. So yeah, with that topic, I noticed there's a ton of questions. Doctor, you can let me know where you want me to transition from here.
Well,
some
yeah,
of them
this is so interesting, and you know, we've got, you know, great comments and questions that are sort of flooding in. I actually, it's great to see we have participation from Lillian, one of our partners in Puerto Rico, and is sharing some information about some training that's been done on that. And it's so great to see Sea Grant involved with this, Ruby and Dolan and others. Dolan is leading an effort, I think, as well too, to think about different types of mitigation strategies for erosion control, adaptation. And so we're very, very interested in these possible applications, these tests, these pilots that have been done, you know, around Hawaii, but in other locations as well too. So I hope that this is, you know, a continuing conversation. I know that we try to keep these sessions to an hour. So if you have to break off, you can break off, but we're willing to sort of keep it open for a little bit more. I think there will be a recorded version of this, and we will try to connect each other in terms of this topic, in terms of vetiver specifically, but green infrastructure more broadly. I think great questions about the scale or the appropriate level of intervention and how we can do more together on this. So, so with that, what I would like to do is close the formal portion of the session, but let's stay on and continue to exchange for those who can, recognizing that there may be other commitments that we have to honor. But I want to close by thanking everyone for joining us, especially our presenters, Dr. Khan, that was great, really informative. And the problem with doing it, such a great presentation like that, we're going to bring you into our other classes and our other work as well too. And of course, Jason, it's great to interact with you and to hear about your very practical experience, because at some levels that is what really matters. And I think that this was hugely important. And I want to thank Lily as well. I'm sorry, Sequoia, and then everyone else from our NDPTC team that has joined in with questions and comments about this as well too. So again, thanks to you all. If you want to hang on, ask questions, or have, we'll keep the room open for a bit. See you next month.